Hi everyone, I hope you're okay. This is the fifth video, guys, where I'm tackling past exam question papers concerning organic chemistry. Just stay tuned, guys, and wait for more videos. Before I even start, please do not forget to subscribe. Okay, 2.1, we are told to consider the organic compounds represented by letters A to C. We are given structural formulas, guys. The first thing we need to do is to write down the IUPAC name for all these structural formulas. Okay, and please note that, guys, your longest chain should have the most number of carbons altogether. So our longest chain will be this one. This is our longest chain altogether. And since I have both side chains and the halogen, I must start counting from the terminal carbon that is closer to the side chain or the halogen altogether. So if ever I am if I start numbering there, that will be carbon number 1, 2, 3, 4, 5, 6, 7, and 8. I can see that in carbon number 3 I have my chloro, as well in carbon number 5 I have my chloro there. However, in carbon number 4 I have a side chain, a methyl. So all these are just additions to my alkane, and hence I'll end up having a haloalkane altogether. So whenever I name my compound, I must go alphabetically. If the side chain is the first one alphabetical, I was going to start with it. And if the halogen is the first one alphabetically, I'm going to start with it altogether. I have the halogens that are present there, they are chlorine atoms altogether. So whenever I know that chlorine comes before methane, or methyl rather, altogether. So whenever I name this thing, I'll simply say 3.3 dimethyl, because I have two no, not dimethyl, excuse me, it's dichloro. It's dichloro, and then 4-methyl octane. It's octane since the number of carbons on the longest chain is 4. Then compound B is quite simple. I'm dealing with the primary alcohol that has 4 carbons. It's just butane 1-ol. Compound C is also simple. I have a ketone. Why do I say I have a ketone? Because the carbon that has a double bond O is bonded to other 2 adjacent carbons. And the name of this ketone is just propane 2-one. Even if you just said it's propanone, you are not going to be incorrect, because there's one type of propanone. It's just propane 2-one. Okay, now let's answer the questions. Write down the homologous series to which compound C belongs. We just said compound C is a ketone. And then the IUPAC name of compound A is 2. Why did I say 3.3? Oh, it's 3.5. In carbon number 3 and carbon number 5, I have chlorine atoms. So this is just 3.5 dichloro, and then it's 4-methyl octane. 4-methyl octane. Okay, and alcohol and methanoic acid are heated in the presence of a concentrated sulfuric acid. What is the role of a concentrated sulfuric acid in this reaction? This type of reaction is esterification altogether. The acid plays 2 roles. Firstly, it speeds up the reaction, and secondly, it acts as a dehydrating agent. Okay, and then 2.2, we must write down the name or formula of the inorganic product formed. Always the time, guys, whenever you form an ester, the inorganic product that you will form will always be water, H2O. Okay, and then now you're told that the ester contains 6.67% of hydrogen, 40% of carbon, and 53% of oxygen. And the molar mass of the ester is 60 grams per mole. They want us to find, firstly, the empirical formula. How can you find the empirical formula? It's quite simple. I have a carbon, hydrogen, and oxygen, and I'm told that my hydrogen is 6.67%. Whenever you are given percentages, guys, if you are dealing with empirical formula, you must always change it into grams. The 6.67% will be 6.67 grams, and then the 40% of carbon will be 40 grams, and then the 53.33% will be 53.33 grams. Then the number of moles, we'll simply say it's mass all over molar mass. So here I'll simply have 40 divided by 12. Remember that, guys, the molar mass for carbon is 12 grams per mole. For hydrogen, 1 grams per mole. And then for oxygen, it's just 16 grams per mole. Ne? So when I say 40 divided by 12, I'll simply get 3.33. And then 6.67 divided by 1, that's 6.67. And then 53.33 divided by 16. What do I get? 53.33 divided by 16. This is 3.33. Okay, so the smaller number of moles is 3.33, right? So I'll divide each and every number of moles with the smallest out together. So I'll say 3.33 divided by 3.33 to find the subscripts of my empirical formula. And then 6.67 divided by 3.33. Then 3.33 divided by 3.33. So this will give me 1, and I'll have 2 there and 1. So this simply means that the empirical formula is just CH2O. And then now I must find the molecular formula. For me to find the molecular formula, guys, it's quite easy. I must first find the relative atomic mass number of my empirical formula. So that's just 12 for carbon plus 2 times hydrogen, and then plus 16 for oxygen. This will give me, this will give me 30 grams per mole altogether. And then for me to find the molecular formula, I just need to find the ratio of the molecular mass number. The one which was given to me, it was 60 grams all over the 30 grams that I found. The answer is 2. For me to find the molecular formula, I just need to multiply the subscripts of the empirical formula by 2. So what I have to do is to say, since I had a 1 over there, that means I'll say 1 times 2, I'll have 2. And then 2 times this 2 will give me 4. 1 times 2 will give me 2. So my ester is just C2H4O O2, and its IUPAC name would have been methyl methanoate. Okay, write down the structural formula of methanoic acid. The structural formula of methanoic acid. It's simply like this. That's methanoic acid. The IUPAC name of the ester, I just said it was going to be methyl methanoate. How do I know that? I only have 2 carbons. That means it must be like this. And like that. So the IUPAC name of the structure is just methyl methanoate. That's how, guys, you're supposed to tackle this question. Just stay tuned, guys, and wait for more. If, guys, you're struggling with empirical formula, please do just go. There's a playlist there for stoichiometry. Empirical formula is included there, guys. You don't have to sweat too much. This is great and stuff.